Okay, sorry. She thinks I'm talking to my husband, and so that's why she keeps coming here and saying daddy, because she knows I have my phone. Okay, so listeria is found in the dirt. And so a lot of times, like your lettuce or your tomatoes, anything that you buy from the store that says ready to eat, it's always good to wash it again. Sometimes I do, sometimes I don't. But that's the listeria. Sometimes you hear about listeria outbreaks, oddly in like ice cream. I'm not really sure how it ends up there. But anyway, it can be especially on like lettuce and things like that. And so you hear about that pretty common. And again, we're just giving examples of different types of these bacterias in these three major groups. Let me think. What else? Oh, streptomyces. Yes, I thought that was really interesting. It was the common one that lives in bacteria in the soil. It's common bacteria in the soil. If any of you garden, you know that smell. When you start to till up, I love that smell. It's just that rich, musty dirt smell, just the smell of earth. That's what that smell is. It's streptomyces. It's really good for the dirt. It serves a very big purpose. And of course, the book tells us that they've actually used it to make different drugs, make different antibiotics and antifungals and antiparasitics and stuff like that. But anyway, you've smelled that one if you've ever grown a garden in your backyard. I'm trying to think if there was anything else. Like I said, all these are just more examples. Oh yeah, Mycobacterium tuberculosis. That was the big. You used to hear about tuberculosis is rare. I've seen a few people we thought we've had it when I was still working in the hospital, but I don't think I've ever truly had a tuberculosis patient. But not too many years ago, it was really, really bad, and we had all the tuberculosis hospitals. Because it gets in the lungs. Leprosy, I thought that was interesting. The Mycobacterium lepra, which causes leprosy, is usually spread through the air, but I didn't know that. If you walk through soil with an open wound where lots of it is, you can get it. Leprosy is treatable now, okay? I know when we think of leprosy, we think about the Bible times and how they were lepers and they were unclean and they were like kicked out of the community and they had to go live in colonies by themselves. And Jesus healed so many people with leprosy and he would touch them, which was, just preposterous to the Pharisees that he would touch someone so unclean. That he healed so many with leprosy. But anyway, I just thought that was interesting. And there were so many practices that the Jews had that would help leprosy not to spread. And historically, we talked about last week, I talked to some about the witchcraft trials and people being, all the different people at this time who was accused of that because sicknesses were spreading like crazy and they didn't have an explanation. They didn't understand all this stuff. So they would blame all these sicknesses on witches because they didn't know that bacteria existed. Well, in that same phase, I learned recently that a lot of Jews were, we know, of course, through Hitler and the Holocaust and all that, but even before that, a lot of Jewish communities were blamed for sicknesses because everybody around them would be sick and carrying all these different diseases passing around the communities, but the Jewish people would not. But what it was is God in all his infinite wisdom had laid forth in the old law all of these laws about what was clean and what was unclean and all this hand washing and all the laws that they had to do under the law of Moses was actually to prevent the spread of bacteria. God knew that. They didn't understand why. They just did it because God told them to. But they actually were cleaner and they didn't spread diseases as much. And so the other people who didn't have these laws that they followed, like the Jews did, would look at the Jews and be like, well, they're not getting all the sicknesses. They must be the reason they're causing it. But it was just their cleanly practices kept bacteria from spreading so much. So they wouldn't get as sick as the other cultures and stuff would. Anyway, I just thought that was really interesting. Okay, that was a side note. That one was free. That is not on your test. I just thought it was cool. Okay, anyway, tuberculosis and leprosy. That's that. Now, the last section, next to last, talks about viruses. So viruses is all of them together. Viroids are them individually. And I'm not really sure how to say that last one. The pyrons, those are at the end. We'll talk about those in a little bit. But viruses are really creepy. They're interesting, but they're very creepy. It talks a lot about how they're wrapped in the capsoid, which is on the outside. They are not living. They have to have a living host to replicate. So it seems like they're living, but they're really, they're not. These are all the different shapes they can come in. They can come in more than this. Of course, we're all familiar with the corona shape, which actually he didn't picture here. But that's another shape that it can come in. Corona is the shape of the virus. When we get to talking, obviously all the COVID stuff. And then this one I thought was the definitely strange, creepy looking shape that it comes in. But anyways, so like I said earlier, they have to attach, and they only will attach to a specific host, okay? And so you have target host and target cells. So that's why typically a dog virus can't cross to a human virus can't cross to a plant viruses can't cross to a dog. They all have very specific targets that they need. So once they attach to that target, they have to penetrate it and inject it. Okay, so they penetrate and inject their nucleic acid. Viruses are only made out of two things. Okay, all they have is proteins and nucleic acids. The proteins is part of their capsid that wraps up their outer part of their body, and then the nucleic acid is what is on the inside. So they inject that nucleic acid into their host that they have decided to try to invade, and that's when it gets inside, and it starts to gets inside the cell, and it starts to duplicate and whatnot. Anyway, all that goes deep into it. This was a really good, well, before I turn that, lysis, you're going to need to know that too. It refers to the cell plasma membrane breaking down and spilling out into the environment. So this does a really good job explaining it here, okay? So the same thing happens in both of these cycles, all right? It can do one of two things. The virus goes into the cell, and so here, that's the red part. Here we have its nucleic acid is all mixed in the DNA of this regular healthy cell, okay? If it's lysogenic, it's just going to stay in the cell, okay? And then the cell will duplicate, but it doesn't actually leave that cell. It's in this cell, and it's in this cell, and now it's duplicated, and this one will eventually go on and duplicate again, but it's still kind of staying maintained inside that one type of cell, okay? That's the lysogenic cycle. How? Now, this is the bad one, the lytic cycle. That is when it goes in and it starts to replicate, and then the virus reproduces using the cells. So like here, you just have the one. It's not really reproducing. But here it starts to reproduce using all the biomachinery is just the things inside the cell, okay? It's mitochondria, it's nucleus, whatever, all the things inside the cell. It starts using it to reproduce itself, okay? And then when it gets full enough, lysis happens of the cell wall. All right, and this virus busts out, and it goes to spread to all different other types of cells, okay? And that's why you start feeling bad. It starts spreading through your whole body, like if you have the flu or something like that. And it repeats that until your body's immune system can get a hold of it. Now, fortunately, not only does it inject its nucleic acid, it injects a little bit of that protein that makes up its outer coating, that capsid, okay? And so when your body sees the proteins from that virus, that it recognizes as a foreign invader, okay? That triggers that immune system response where your body starts building up its little soldiers to go and attack that virus, okay? So thankfully, as it's inserting its nucleic acid to duplicate, it does give a little bit of its protein. And so eventually the body recognizes enough of the protein and it starts to attack it. And eventually the virus's life cycle will end and you'll get better and you'll quit running your fever because your immune system finally catches up. But it does sneak in there and start multiplying for quite a while before your body recognizes the fact that it's in there. And that's because I think it injects more of the nucleic acid than it actually picks up of the protein. But as far as your understanding, it injects nucleic acid. That's what the purpose of the virus, that's what it wants to do, is to inject that into your cells. Okay, so that's that in a nutshell. A latent infection, that's what the lysogenic cycle has. Latent, I think of it as like lazy. That's what I think of when I think of latent. I think of lazy. And so it's there all the time in your cells, but it's not causing any trouble yet, okay? Like it talks about the shingles and chicken pox and stuff. Chicken pox is what you have when you're a kid. It's the same virus, Varicella zoster, that later in life will be the shingles. But say your body gets stressed by sickness or even mentally stressed, or you're not getting enough sleep, you go through something that stresses your body out. These latent or lazy viruses hanging out in this lysogenic cycle can activate and turn into the lytic cycle and actually go active and start making you feel bad. And then your immune system has to fight that back off again. Okay, so that's that. And one more thing. So this just talks about the size, how little, like bacteria is super little, right? Viruses are even smaller. And then a single viroid is even, it's so small, it's hard to wrap your head around, okay? And so what it takes to filter out a virus is crazy, okay? So I say that to say, I guess this could be controversial, but I'm gonna say it anyway. Paper masks, like everybody had to wear during COVID, right? They don't do anything. If you understand viruses and virology and the things that you're learning in this chapter, they don't do anything. They're nowhere near a small enough filter to filter out viral particles. Now, the thought is if you cough and sneeze, your mask helps you not spread as many out. And that, yeah, I could see that. You know, if you're coughing and sneezing, it does hold some in, but it's still a lot that goes through it. And if there's a virus floating around in the air and you're wearing a mask and you're breathing, it's going to go right through that mask because it's not a small enough filter to filter out. That's how little these viral particles are. Okay, so that's why there was a lot of controversy there. Some people were demanding people wear them. Other people were frustrated because they understood that they actually weren't doing anything because viruses are so small they can go right through the paper mask. But anyway, there was that whole debate. But it was just covered a little bit here, and I could tell that's kind of, I felt like where he was getting at, was just trying to help us understand how small viruses really are, and what it actually takes to filter it out of the air. Okay, so there was that. Oh yeah, the Pyron, that was really interesting. It was just, hang on, let me pause this.